Kia ora, Year 13. Here's the second part of question 2 from last year's probability distributions paper. So this one is all about the normal distribution to start off with, and it starts with an achieved question, then there's a merit question and a harder excellence question. So we're told that the average temperature in a New Zealand living room on a winter evening can be modelled by a normal distribution with mean of 17.8 degrees Celsius and standard deviation of 2.1 degrees Celsius. So using this model, between what two values would you expect the middle 95% of average temperatures for New Zealand living rooms on a winter evening to be? So if you've got a graphics calculator, this question is extremely straightforward. I'm going to draw a graph, and if you're in my class, you know that I'd really like you to draw a graph. I know you're going to ignore me, but there you go. What we're looking for is those two values such that we get 95% in there. So using your graphics calculator, you're going to go to stat and then, as usual, get through to dist and get right through to norm. But the bit that you want then is norm and then inverse normal, right? So we want the inverse normal when we're working backwards to find these values. If you've got the Casio Blue calculator, you're even luckier because you can go to data variable and then you're asked which tail you want to find. But one of the options is that you want the central area. So if you choose central and then put in 0.95, mu of 17.8 and sigma of 2.1, the calculator will do all of the work for you. So it will give me the lower value will be 13 point, let's round it sensibly, so I'll go 13.68 and the upper is 21.92 degrees. Now I haven't rounded to 1 dp because I'm probably going to I might use these numbers later on, so I'll just put in brackets what I've done, just put 2 dp. One is fine as well. I wouldn't go any less than that. So just if you are getting hung up on rounding, what I'm thinking about is that these numbers were given to me with 1 decimal place. So usually I'll go to 1 more degree of accuracy than that. Okay, so that's the first question done, and that's an achieved tick, amazingly. Next, we have to discuss one factor that should be considered when modelling the average temperature. So here you need to show that you understand real life. So let's think about some things that could affect our model. Well, don't say that it depends on the season because we've been told that it's in winter. But a big difference is where in New Zealand, right? So the average of 17.8, if you think about somewhere up north, pretty sure Kerikeri is 2 words, or in Invercargill, you're going to have quite a different model depending on those factors. Or you could just say north versus south. South Island will tend to be colder, although there are exceptions to that rule as well. The next thing that you might want to talk about is the idea of a microclimate or something like that. Doesn't need to be that fancy a word. Is the house on a hill? Is it exposed to the southerly? And so on. So linking to the context. And then the last big thing with New Zealand houses is how old's the house? So how old is it? What building materials? What's it built from? Old houses tend to be less well insulated, draftier, and you'll have wind coming in under the front doors and through the windows. So insulation is a big thing. So any of those things, if you discussed in context how they would affect the model, or just one factor that should be considered, you'd be fine. And you get a merit tick if you get all of that right. Now the next part of the question is the excellence part, and this is it here. Right, so let's read it carefully. Suppose that 5 New Zealand houses were selected at random, that's a good thing, and it was found that the average temperature of the living room on a winter evening was below 16 degrees for 4 of these houses. So at this point you should be thinking binomial with n equals 5, right? We're modelling how many out of 5 had a temperature below 16 degrees. And that's even before I've read the question to check that that's what's being asked for. Would finding 4 or more houses out of 5 with an average temperature below 16 be unlikely under the probability distribution model described above? In other words, we started out this question assuming that the mean was 17.8 and sigma was equal to 2.1. So what we're asking is, first of all, what's the probability using this model of getting a house with an average temperature below 16 degrees? And then what are the chances that out of 5 houses, 4 or more have this? So the first step in here is to go to your calculator and find the probability that x is below 16. And if you do that, using this for mu and this for sigma, you get 0.1957. So this is going to be the probability that we use in our binomial problem. So we want a binomial, n is 5, p is 0.1957. Remember, the binomial model is a big extension of a tree diagram going out to 5. So we want to find the probability that 4 or more have got a low temperature. So the probability that 4 or more houses is equal to the probability of 4 or 5. I'm going through this pretty slowly. But if you're really wanting to check that you've got the right ones included, we want the 4 or 5, but we don't want these ones. Your calculator works with the lower end, so we're going to switch it around. So the probability of finding x greater than or equal to 4 is equal to 1 minus the probability of x less than or equal to 3. So grab your calculator and figure that out, and you should get 1 minus 0.9938, which gives us 0.0062. But that's not the end, because we're asked about how likely it was to happen. So we need to make sense of that answer. So what we're saying is that if the model is true, if the average temperature is 17.8, the probability of finding 4 or more houses with a temperature of 16 or below 16 is extremely unlikely. So extremely unlikely to find 4 or more below 16 degrees if model is correct.